So here I have a spreadsheet where I'm comparing simple interest to compound interest. So I'm starting with $1,000, and this 5% is an annual percentage rate. So I'm going to label that APR. Over here, I calculate what happens with simple interest for 1 year. So 1 year later, we would just take that $1,000, multiply by 5%, and that's the answer. You could also multiply by the 1 year, but multiplying by 1 doesn't change much. So I'm using that formula PRT for simple interest. And that gave me 50 bucks. So if you're collecting interest in a simple interest manner, which is kind of how dividends work, you simply get just another 50 bucks each year. So here I have 1,050, and then another 50 is 1,100, add another 50, I get 1,150, add another 50, I get 1,200. So this right here is just a simple linear increase. $50 a year, that's it. My interest doesn't collect interest, simple interest. Compound interest is that formula that we were messing around with, where we have to use a power to the 1 plus R. So I just want to write a quick note about that, and then I'll show it to you in the spreadsheet. So applying this formula right here, where we only get interest once a year. And even when I use a spreadsheet, I write things on paper first. So I've got my formula where A is P times 1 plus R over N to the power NT. And the situation I'm looking at is my P is $1,000 to start with. My rate is going to be 5% APR. My N is going to be 1 because I'm only getting interest yearly. And then as far as T goes, I'm making a table where T is going to be 1, and then 2, and then 3, and then 4, and then 5 years. So I'm just going to clean up this formula a little bit, but I'm going to hold off on plugging in T right now. So for the spreadsheet problem, I want to take 1,000 times parentheses 1 plus 5% as a decimal. Now I'm dividing by 1, but that's kind of boring. Not much changes when you divide by 1. And the power would be 1 times T, but 1 times T is T. So that cleans up a little bit. 5% divided by 1 is just 5%, plus 1 is 105% as a decimal. And there's the power T. So this cleans up pretty nice here. Now I can't do that multiplication until I know what T is, so this doesn't simplify any further. It's as far as I can take it. But that's what I need in my spreadsheet. So I'm going to show you how to put that in a spreadsheet, if you want to use a spreadsheet as a calculator, because it can be pretty quick. So I'm going to reproduce those numbers right there. So I'm just going to do it in the column next to it to see I get the same numbers. So compound interest abbreviated. And let's minimize that so I can see more. Anytime you want to do a calculation on a spreadsheet, you got to start off with equals. So I click in that cell and then I type equals. Now I could click on the 1,000, but that's a little trickier. I'll show that another time. I'm just going to type my 1,000 like I had it on my paper, times parentheses, and I simplified my expression to be 1.05 for the base inside the parentheses. And then on a spreadsheet, a power is that shift 6, that little hat key. It's called a caret. That means whatever comes next is an exponent. Now, if your exponent is complicated, then you got to put it in parentheses. If it's just a simple thing, you don't. My exponent in this case is just the number of years over here in column A. So I'm just going to click on that right there. So my formula says calculate equals 1,000 times 1.05, right? My initial investment is the 1, and then the 5% is the 0.05, raised to the power whatever the number of years is that's gone by. And when I set it up this way, with the number of years being a variable coming from that column over there, I can fill this formula down. So I'm going to hit enter. It's going to give me that number right there. I can say, hey, make it dollars so it's pretty. There's a little button up here to format as currency. And since I typed a formula there, if I did it right, I should just be able to fill it down. And then it should give me all the right values there. Okay. So again, to make that formula happen, I started off with equals 1,000 times the 1.05, parentheses are optional there, but I'm going to put them in anyway, raised to the power how many years have gone by, which I just tell the computer where to look for it. And then that formula is fillable when you click back on it. Notice I get the same numbers there. And it just shows that compound interest is better than simple interest because your interest collects interest. So next class, I'll show a slightly different way to do that on a spreadsheet. And there's a homework problem related to this where a spreadsheet could be really helpful. So let's get out of here. Again, compound interest formula, super important. And that's about all I have for now, unless